Going over the question for this week. This is for the first slide. Number one, say if they're independent or dependent. So if you roll a die twice, that is independent, because whatever you get on the first try doesn't affect the second try. Flipping a coin twice, the same. Okay, a bag has 2 red marbles, 5 green ones. Okay, once you draw one out, once you take one out from the bag, it is now what's left is not the same ratio as before. So the probability actually does change depending on what you pick out. So it is dependent. Right. Next one. A bag has 2 red marbles, 5 green ones. Now they pick one and then they put it back. So if they put it back every time, they are resetting the whole probability. So whatever you get on the first one doesn't affect the second try. Last one. You and your friend are in a draw for prizes. You can only win one prize. First, your name is drawn, then your friend's name is drawn. So is that dependent or independent? That's dependent, because there's only one prize, one person gets it, the next person does not. Okay, 1 cube is taken from each of these bags. What is the probability that they are both blue? So let's think about the probability in the left bag. Getting the blue one out is 3 out of 4 cubes. That's the probability, which also is 75%. Okay. The next one is, we can't say it's 2 over 4, which is also 1 over 2. Right? Now, if you want to know two things, the probability of two things both happening, we multiply these two probabilities. So we're going to go 3 over 4 times 1 over 2, which happens to be 3 over 8. And in decimal, I am just going to go 3 divided by 8 in my calculator, get 0. Oh, what has happened to my pen? I'm sorry, did something weird there. 0.375. Right, 3 divided by 8, I get that on my calculator. Percentage, I times that by 100, which means I get 37.5%. Done. Next. You roll a standard 6-sided die 3 times. What is the probability that you will first roll a 1 and then an even number and then a number greater than 4? There's 3 things happening here. Okay, the first one, you roll a 1. Okay, rolling a 1 is 1 out of 6 chance. There are 6 sides of a dice. We're aiming for 1. Even number, we have 3. So again, we're multiplying, by the way. It's 3 over 6. Or it's half a chance. You can say 1/2, and that's just as good. And then a number greater than 4. Now, if you think about the numbers on a die or on dice, there are these numbers. Number greater than 4, it's 5 and 6. So that is 2 out of 6 chance. Or you can say it's 1 over 3. Still the same thing. So you do this either on paper or in your head, and we get something rather. You know what? Let me simplify it. Times 1/2 times 1 over 3. Okay, cool. This gives me 1 over 12 times 3, 36. Okay, cool. 1 over 36. In decimals, I go 1 divided by 36 on my calculator. I get 0.02777777. So I'm going to go 7, and we're just going to round it up to 8. Oh, wait, it says 2dp. Sorry about that. It should be just 2.8 then. Rounding it up. Percentage, I times it by 100. I get 2.8%. Okay, number 4. Dylan is cleaning his fish tank. He has 4 goldfish, 8 clownfish, 7 suckerfish, and 1 minnow. He takes the fish out before he cleans the tank. What is the probability that the first 2 fish Dylan pulls out are both clownfish? Now, first time, I'm assuming Dylan is taking out fish randomly and he's taking out fish one by one. So the first time, let's find out how much fish or how many fish total in the tank. And I think that goes to 20. Am I right? Yes, 20. There's 20 fish in total. How many clownfish? 8. So that's 8 out of 20 chance to begin with, if I am picking out one, which is also 2 out of 5. But I'm gonna stick to 8 over 20 just because it makes better sense how I got there. Now, the second fish now is different. Now, having imagined that we've taken one clownfish out, the new probability of taking another clownfish out, there's no 8 clownfish in the tank anymore. There's 7. And in total, there's not 20 anymore. There is 19. Right? So if we work that out, I'm just going to use a calculator for this one because, of course, this is getting larger and larger in numbers. Let's save us some time. 14 over 95. Right? We work it out in decimals, so we do 14 divided by 95. Or if you have a calculator and you've already have it in fractions, you can click on this button and it changes it to decimals for you. You can do either one. But anyway, I get 0.1473. It goes on, but I'm going to, because it's 147, I'm going to round it up to 15, 2 decimal places. Percentage, it's 15%. Oh, wait, which means that's not 2 dp. Why did I do that as 3 dp? That should be that. Anyway, there we go. Number 5, 2 chocolates are eaten from a box of milk and dark chocolates, as shown in the probability tree below. So there's a probability tree. So going over this way, the first pick, the chance of picking milk chocolate is that. The chance of taking dark chocolate is that. And then second pick, it's already done for us. There it is. So what is the probability that they are both dark chocolates? So both dark chocolate is when we go down this way. This one. If we pick that one, and we also go this way again. So we're having both of these things happen. So we're going 30 times 11 over 29. And that's, again, multiplying is how we figure out the probability of 2 things happening, both of them happening. Now at this point, that number's like this. I will default to a calculator to work this out. And once I do, I get fraction. I get 22 over 145. Right? I'm using the fractions function to do this multiplication. And then the calculator will give me a fraction. The decimal is 0.15. The next number is a 1, so I can round it down this time. I don't need to make it to 1/6. Percentage is 15%. All right, onwards. Section B. A card is randomly drawn from a standard deck of 52 cards. What is the probability that the card will be an ace or a king? So if I'm saying one or the other thing, or another thing, I can add both of those probabilities up. So what's the probability of me getting an ace? There are 4 aces in a deck. So that's 4 out of 52 cards. Right? But I'm saying it's also okay if I get any of these. That's another 4 over 52. I'm going to plus them. So the probability I will draw an ace or a king, I add those probabilities up. Again, the probability is made up by the chance, the thing that I'm going for. So there's 4 of them in there over the total, which is 52 cards. So that's the probability. That fraction is the probability. Okay, fraction. It is 8 over 52. You can simplify that as 2 over 13, but either way, decimal. Decimal becomes 0.15 again. The next number is a 3, so we are rounding down. Percentage 15%. Moving on, number 2. A box contains 20 red, 10 blue, and 30 yellow beads. What is the probability of a This is not bread, by the way. This is, of course, they wanted to say bead. Drawn at random, being yellow or blue. Okay, probability of drawing a yellow bead is 30 over, there's 30 yellow. How many is it in total? 60. Okay, cool. Which is also 1/2. Okay, the probability of blue is plus 10 over 60. Right? So there we go. That equals 40 over 60. Right? Remember, when we're adding fractions and the bottom denominator is the same, 60 and 60, we can just add the top bit and we're good. So that's 40 over 60, which we can simplify as 2 over 3. Right? Decimal being 0.67, percentage being 67%. Okay. What is the probability of rolling 2 dice and rolling at least 1 4? Okay, I'm going to do this in a little bit of a strange way. I want to roll at least 1 4. I want to know the chance. I'm going to go about this by working out what's the chance of me rolling 2 dice and rolling no 4s. And then I'll work backwards. So, let's say I roll 1 die. What's the chance of me not rolling a 4? It is 5 out of 6. Okay, what about the chance of me rolling the second die and also not rolling a 4? That is 5 over 6 again. So, what is the chance of me rolling 2 dice and both of them not having a single 4? It is both of them happening at the same time, so we multiply. And we get something like 25 over 36. Right. This is not the probability we're looking for. This is the probability of no 4s in 2 dice rolls. Cool. Now, having at least 1 4 is going to be the remainder of this probability. Remember, everything adds up to 100%. So if it's a fraction, it's going to add up to 36 over 36. All the probabilities put together. So if the probability of no 4s is 25 over 36, what's the remaining probability? So how many more can we put in into 25 to get 36? So I'm going to say 11. There's 11 out of 36 chance left where I might get 1 or 2 4s. Now, decimal. Again, I just go 11 divided by 36. I get 0.69%. Oh, no, that's the other one. That's the percent of this, actually. I've done the wrong thing. 11 divided by 36 again. Let's try that again. 0.31. Percentage, 31%. Times by 100. Now let's carry on. Number 4, a weather forecaster states that the probability of rain is 3 out of 5. The probability of lightning is 2 out of 5. Oh, let's just do that again. The probability of having rain and lightning at the same time is 1 over 5. Okay, what's the probability of the sports event being cancelled due to rain or lightning? So if there's either rain or lightning, they're going to cancel this event. So this one is called mutually exclusive. Non-mutually exclusive probabilities. But let's have a think about this. The possibility of there being rain is 3 over 5. The possibility of there being lightning is 2 over 5. Now, if there's either of these, we cancel the event. So we are thinking an or kind of situation. So we're trying to add it up. But there's a problem here. Inside this probability of 3 over 5 of being rain, we are also including the probability of there being lightning as well. Right? So out of 3 out of 5, in here, out of the 3 out of 5, 1 over 5 of these, 1 over 5 of the chance, which is 20%, is lightning being together with the rain. This happens here as well. It happens here as well. If we count up all the possibility of there being lightning, we are also counting the possibility of there being lightning alongside rain as well, which is 1 over 5 of that probability. Actually, which means I should actually draw this to be quite larger. Okay. Right. So which means if we just add them together, we've added this bit and this bit twice. We're counting these possibilities of there being both lightning and rain. We're counting them twice. So here's what happens. We have to go 3 over 5 plus the 2 over 5. That's the possibility of lightning. But since we know we've counted the case of lightning and rain together twice, we have to minus this one time. So we end up getting 4 over 5. Decimal being 0.8 and percentage being 80%. Cool. Number 5. Mila sometimes has trouble getting ready for school on time. The probability that she will be late or not late to school this week is shown in the probability tree below. Okay, so 70% chance of being on time, 30% chance of being late. Let's have a look. What is the probability that Mila will be late exactly once on either Monday or Tuesday? Exactly once. So we are looking at 2 possible events. On time on Monday, but late on the Tuesday. Or we are looking at the case of late on the Monday, but on time on the Tuesday. Okay? So let's think about this. So this path here, what's the probability? Remember, if we want both of these things to happen, we multiply. We multiply their probability. So we're actually going to go 0.7 times 0.3. We're not going to change the fractions right now. Not at the moment. Let's just carry on like this, which is 0.21. The same for this actually, because 0.3 times 0.7, that's the same thing. So again, 0.21 here. Okay, so if we are saying the yellow path or the blue path, either one is fine, we add these probabilities up. So it's 0.21 plus, 21 plus 0.21, which is, let me write it over here, oh, not fraction, it's a decimal, 0.42, which is 42%. And changing from decimal to fraction, we can just say it's 42 over 100. Right? Because that's a tenth and that's a hundredth. So 42 hundredths is 0.42. It's the same thing. Or you can think about the percentage being 42% being 42 out of 100. So we get this fraction. We can simplify this fraction and get something like 21 over 50, sure. But regardless, that's how we can get the fraction. Moving on. Section C, this is the last section. A coin is tossed 80 times, lands on tails 44 times. What is the experimental probability for landing on tails? So experimental, so the ones that we've observed, having done it and seen, experimental probability of tails is 44 over 80. And we can do that on our calculator to see what comes out. Of course, we can simplify it, but I'm going to skip simplifying it for now. 0.55, which is 55%. Theoretically, we imagine it to be a half, which is exactly 50% probability. So it's pretty close, but not exactly the same. That's fine, we move on. We've done that question. 2. A survey was taken to find out what students drank for breakfast. The results are shown in the table below. Here we go. What is the experimental probability that a student drank an apple juice for breakfast? Okay, so let's have a look. It's 11 out of something. That something is the total number of students we've asked. So let's add these up. So that's 11 plus 17 plus 22, which gives us 50. So the fraction is 11 over 50. Decimals, if you go 11 divided by 50, we get 0.22, and that is 22%. Number 3. Using the information in the previous question, how many students would you expect to buy an orange juice if 100 students were surveyed? Well, let's have a look. Orange juice probability here was 17 over 50. 17 over the total of 50. Right? Cool. But we are making a guess about if we asked 100 students, how many of them would have bought orange juice? So this is out of 50, but if we want it to be out of 100, what do? We double that number. So it's not 17 out of 50. We would say 17 times 2, that's 34 out of 100, right? Because that is the same as 34 out of over 100. So 34 students, boom. Next one. Sierra asked her classmates about their favorite color. She found that the experimental probability that a student selected blue to be, that's really tiny looking, that's 2 over 5. How many students selected blue if there were 25 students in her class? No, that's the same thing again. So let's just write it down somewhere else. 2 over 5 equals something over 25. What do we do to make that 25? That's times by 5. So, right, that's scaled up by 5 times. So 2 times 5 is 10. 10 students. So because 2 over 5 is the same as 10 over 25. Cool. Number 5. Zaira draws a marble out of a bag, or I think that's supposed to be of 30 marbles. Records the color, interesting spelling for color, and replaces the marble. She repeats her experiment 6 times. Her results are shown in the table below. So first time, got a blue, put it back in. So because it's replaced every time. Next time, got 2, put it back in. Got blue, got red, got blue, put it back in. Now, Zaira concludes that there must be 10 red marbles and 20 blue marbles. Do you think she's correct? Why or why not? So, experimental probability, that is 1 over 3, and that's 2 over 3. So if we did work, and make that something over 30, because I know there's 30 marbles altogether, yep, the red would be 10. And the blue, 2 over 3, if I change that to something over 30, that would have to be 20. So ratio-wise, it seems pretty good. The probability looks about right. It's the best guess we have so far. However, from a bag of 30 marbles, doing it only 6 times, it's really not much. So we cannot really conclude anything. We just say, we don't know yet. It's quite likely that Zaira's wrong. And why or why not? Because, well, the trial number should be larger than 6. We should do this more times. And I'm not going to write all this up, but we say, the proportion seems about right so far. However, we need more trials to be more confident in what we think. Who knows? There might be even other colors in here that we just haven't seen just by chance. So we don't even know if it's only red and blue. So we need to do it more times to be sure. There you have it. That's this week's Worksheet, I know I went pretty fast. I just went through it. If there is a question you want me to go slowly and explain fully, email me about that question and I will talk about it. I'll talk about why we solved it like that, and I will talk about all the steps. But for now, this is the whole rundown of the worksheet this week. All right. Take care, everybody.